Hello everyone, today I'm going to be teaching you how to use joints in Fusion 360, what different types of joints there are, and how you'd use each joint. So, what is a joint? So a joint is a connection between two different components, assemblies, whatever you want in Fusion 360, and it'll stick them together, and depending on what type of joint you use, the components will behave differently in relation to each other. So to start by clicking the joint function, and first select whatever area you want your joint to be. So I want to connect the center of this face to the center of this face. So I'm going to click on this first, and then I'm going to click here. As you can see, the first component that I clicked was this one, and you can see that it moves to the first component always moves to the second component, and that's one thing that you should remember when using joints in Fusion 360. As you can see, it's in a rigid joint right now. You can edit it while it's still in the joint function, but once you click OK, it's gonna be like those two pieces were welded together, and you can't really move them much so afterwards. So once you're done, click OK. That's a rigid joint. After the rigid joint, the next joint is the Revolute joint. And the Revolute joint is like the clock hands on a clock. So the clock hands usually spin around one small pin, and the pin is driving the clock hands, and that's what the Revolute joint basically is. So to start, select the face in which you want to spin first, and then select the face you want it to spin around. Remember to always select the corresponding part, because otherwise your joint will turn out badly. As you can see, right now it's in the rigid joint form. In order to change that, you can go into motion, type, click Revolute, and it'll start spinning, just like a clock. You can click OK, because your joint's working the right way. And then here you can drive the joint. You can manually change it by right clicking on the joint and clicking drive joint, and you can manually change it, or you can enter your own degrees of freedom you want in your joint. It's the Revolute joint. After the Revolute joint is the Cylindre joint. So the Cylindre joint is an interesting joint because it's a joint where the two faces don't necessarily stick to each other. They move, but they're still connected along the same axes. So you'll see once I show it to you. So same thing as last time. Start the joint function. Click the face you want your joint to be, and then click the corresponding face on your other part. So here that'd be there. As you can see, it's spinning, but that's because we used the Revolute joint last time. So go into motion, type slider. Right now the Cylindre joint isn't sliding the way I quite want it to, because I want it to slide down and up instead of side to side. And you can change that by selecting the axis you want it to slide on. One important thing to remember is the axis of movement is always dependent on whichever way the joint is facing, not whichever way you're facing. So if the joint is facing up, the y-axis would be this way, x-axis would be that way, and z-axis would be this way. But in our case, the joint is facing this way, so the y-axis is this way, x-axis is this way, and z-axis is that way. So click OK. Same thing as the Revolute joint. You can drive it by right-clicking on it and clicking drive joint, and you can manually edit it. So that's one cool thing you can do. So that's the Cylindre joint. After the Cylindre joint is the cylindrical joint. So one interesting thing about the cylindrical joint is it's basically a combination of the Revolute joint and the Cylindre joint, and it's really useful for screws because it allows your part to move up and down as well as circular. So just click joint, select your face, and then select the corresponding face on your other part, As you can see, right now it's moving the same way as the slider, and we can just change it by going to type cylindrical. So right now it's not moving the right way, but that's because our axis is changed. Last time our joint was facing this way, but now it's facing up and down. So we have to change it. Depending on where the joint was, it's facing here, so this axis is going to be the z-axis. And as you can see, it's spinning and moving up and down. Same thing as every joint. In order to drive it, you can right click on it and then click drive joints, and you'll be able to move it up and down as well as spin it. So that's it. So after the cylindrical joint, the next joint is the pin slot joint. So the pin slot joint is also a combination of the Revolute joint and the slider joint, except this time they're in different directions. So the cylindrical joint kept the rotation and sliding in the same direction, while the pin slot joints allows you to change the rotation and sliding movement. So same thing as last time, go into joint, like every other joint, select where you want your joint, and then select the corresponding face on your other part. As you can see, right now it's moving the same way our cylindrical joint is, but go into motion, type, pin slot, and it's moving the exact way I want it to. One cool thing about the pin slot joint is you can change whichever way it slides, and you can change the way it rotates. So if you want it to rotate around the y-axis like that, you can do that, or if you want it to rotate around the x-axis like that, you can also do that. But for us, we want it to rotate around the z-axis, and you can also change the way it slides. So if you want it to slide on the y-axis, you can do that, or if you want it to slide the x-axis, which is what we want, you can also do that. So that's the pin slot joint. After the pin slot joint, last but not least, is the ball joint. So the ball joint can be used by many different objects, but it's best used on balls, hence the name. And in order to use it, same thing as every other joint, go into the joint function, except when you're selecting your ball, there's only one place you can really start your joint, so just click on that. But here you can see two. This is the edge. We don't want that. We want the inside sphere. So we're going to click on that, and you can see that right now it's in the pin slot joint. Can't really see it. And then change it to ball. And as you can see, it's moving all around, and that is the ball joint. You can click OK. Same thing as every other joint. In order to drive it, right click, drive joints. You can spin it. You can change the axis one way and the other. So that's the ball joint. The last joint on the list is the planar joint. So the planar joint is just basically free moving, except it's constrained to one plane, hence the name planar joint. It's like putting a box on a table, which is what this example is, and you can move the box in any direction, except you can't lift it up or you can't push it through the table. So same thing, joint, select your component, first component, and then select your second component. It's moving. Right now it's moving in the ball joint form. That's not what we want. We want it to be in the planar joint. And as you can see, it's moving while spinning, and it can move this way, that way, whichever way you want it. And same thing as every other joint, you can just click drive joints, and you can move it any way you want. So you can see you can move it that way, you can move it this way, and spin it. And this joint is if you just wanted to show someone moving something across one plane, this is the type of joint you use. So these are the different types of joints in Fusion 360. So depending on what kind of use you want, just think about what kind of movement it is and how you use the different types of joints to use it. So one example I had was the universal joint, because it's a interesting joint because you're able to move the joint in every single direction. So this is a universal joint, and as you can see, you can just it's a very interesting joint because it allows degrees of freedom, and it allows you to change the way power came using the joint. So let me just activate it for you for a second. So I'm just going to drive this. So let's move this a little bit. Let's move this one too. So what this is going to do is it can take an axle or any shaft of power this way, and it'll be able to spin, and it'll be able to transfer the same power that way. So that's one interesting use of joints that we've seen in FTC. Well, anyways, thanks for watching. Hope you learned something today, and please watch the rest of the presentation.